Okay, today we'll continue from where I had done last. Refraction of light. Last time I told you that is the bending of a ray of light from one medium to the another medium from the surface. During refraction, frequency of light does not change. There are two laws of refraction. First law says the incident ray, the refracted ray, and the normal, they all lie in the same plane. Second law says sin I by sin R equal to constant. That constant is mu, refractive index. The second law is known as Snell's law. Sin I by sin R equal to mu. Now further we have to know what is the refractive index of medium, Ri of medium. Notes I will send later because the note with the other group is not complete. Once it is complete, then I will send it. What is the refractive index of medium? We denote this by the symbol called mu. Mu of n we can write. The refractive index of a medium formula we have C upon V. What is C? We write over here. C is called speed of light. Speed of light in vacuum. In vacuum, or we can take air. And V is the speed of light in a given medium. Speed of light in the given medium. So refractivity is the ratio of two speeds. Speed of light in the air upon the speed of light in the given medium. And we know the speed changes from one medium to the another medium. So, and that causes refraction. So, refractive index has no unit because it is the ratio of two similar quantities. Both of them are speed and speed, they cancel each other. So, mu does not have any unit. So, refractive index of glass with respect to air, we write like this: glass with respect to air. And the value which will come 1.5. Why it comes 1.5? The reason is because the value of C we put, if you calculate like this, speed of light in air or in vacuum, the value is always 3 into 10 power of 8. Speed of light in the glass, I gave the value 2 into 10 to the power of this to cancel. 3 by 2 divided, answer is 1.5. So on the basis of this calculation, we say refractive index of glass with respect to air is 1.5. 3 by 2 is 1.5. Similarly, refractive index of water with respect to air, we read this way: refractive index of glass with respect to air, refractive index of water with respect to air. That means rays traveling from air to glass. Here it is traveling from air to water. This medium is refracting. Refracted ray you will find here. Refracted ray will be here. This will contain incident ray. Incident ray, refracted ray will be here in this medium. So the value of refractive index of water with respect to air, the value is 4 by 3, or we can write 1.33 or 4 by 3. The value is 4 by 3 or 1.33. Why this is the value? Based on this calculation, we write 3 into 10 to the power of 8 C value, and the speed of light in water. The speed of light in water value I gave already 2.25 into 10 to the power of 8. Cancel it. Divide, we get answer 4 by 3. The answer will become 1.33. 3 by 2.25, the answer is coming 4 upon 3. In decimal, the answer comes 1.33. Sometimes they ask the question: refractive index of glass with respect to air is 1.5. What is the meaning of this statement? We said this statement means that light travels this many, whatever value is given, this many times faster in this medium than this medium. That is 1.5 times faster in air than in the glass. That is the meaning of this statement. Similarly, refractive index of water is 4 by 3. What is the meaning? So, meaning is that the light travels 4 by 3 times faster in air than in water. So, this type meaning type question, statement type question also will come. Okay. Now, suppose I write glass with respect to water and the value I write here 1.25. What is the meaning of this? We read this way: refractive index of glass with respect to water is 1.25. What is the meaning of this? This statement means that the light travels this many times, 1.25 faster in water than in glass. Because water is a rare medium which will travel faster there. 1.25 times faster in water than in glass. That is the meaning of this statement. In this case, the ray is traveling from water to glass. We read this refractiveness of glass with respect to water. We read that way. Okay. Now, refractiveness of a medium with respect to, suppose I say refractiveness of glass with respect to vacuum. Vacuum is we don't write anything. This one is called absolute refractive index. This is known as absolute refractive index. Refractive index. What is absolute refractive index? The refractive index of a medium with respect to vacuum or air, because vacuum or air are very close, with the speed of light in vacuum and in air almost have the same value. That is called absolute refractive index. And here we may not write anything on here. It's automatically either vacuum or air will take. So this is called absolute refractive index. The value of absolute refractive index of a medium cannot have the value less than 1. Its value is always more than 1. Why? Because absolute refractive index formula will be like this of any medium. So this is the medium M. C upon V. That is speed of light in vacuum. Nothing is there in this vacuum. Speed of light in this medium upon speed of light in this medium. Speed of light in vacuum cannot have the value less than the speed of light in the given medium. So its value will always come more than 1. It will never come less than 1. Because light travels fastest where in the vacuum. In another medium the speed decreases. What I mean to say that your numerator will be always bigger than the denominator. That is, your answer will minimum begin with 1 point something. So the answer will always come 1 point something. It will never come less than 1. If your this one is smaller than the numerator is smaller than the denominator, then your answer will come 0 point something, that is less than 1 it becomes. Like 2 by 3, the answer will come less than 1. But if I have 3 upon 2, the answer comes 1.5. With the numerator is more than the denominator, your answer will come always more than 1. Anything but more than 1 will come. So that is the idea. Since C always is greater than B, that is, value is always greater than 1, it cannot be less than 1. Only 1 will come only for air, because the speed of light in the vacuum and the speed of light in other medium are not equal. No? Are they equal? They are even not equal. But normally the speed of light in vacuum and the speed of light in air, they have the value very close. The speed of light in the vacuum is 3 into 10 to the power of 8, and the speed of light in air value is 2.99 into 10 to the power of 8. So approximately 3. When you cancel it, answer comes 1. Then the refractive index of water only has the value 1. We assume this to be 1. Actually, it is not exactly 1. It is coming 1.000 something. Which we round off, approximately we take 1. And that is the minimum value of refractive index, and which medium has air. Air will have the refractive index value 1. And rest all the mediums will have the refractive index value more than 1. It can never be less than 1. Less than 1, no chance. Which has the highest value of refractive index? It is diamond. Diamond has the highest value of refractive index. Now, this is understood? Have you understood this part? Yeah. Now, mu depends on what factors? Mu depends on mainly 4 factors. First factor is density of the medium. If the density of the medium is more, that is optical density, not the weight wise. If the optical density is more, refractive index is more. Optical density is less, refractive index is less. Like denser medium will have high value, rarer medium will have low value. Like I told you, the air value is 1 minimum, because air is the rare medium, approximately 1. It is actually slightly more than 1, but we round off and take it 1. And the denser medium such as glass, such as water, they are having a value higher, because denser the medium, the higher the refractive index. It will cause more refraction. I mean the angle of the bend will be more. The angle between the ray will bend will be more. It will bend more towards the normal, That is the idea. The first factor is the density of the medium. You can just guess hot air and the cold air, which has the higher refractive index, or they will have same. Tell me. Which type of medium will have high refractive index, hot air or cold air? Say one of you. Yeah, cold air will be dense, so it will be having high refractive index. That is the idea, simple idea. Okay, now hot water and cold water. Where the refractive, which type of water will have high refractive index? Higher. Cold or the hot water? Which one? Cold water, because cold water is dense. That means it depends on the temperature also. Second factor. More the temperature, less the refractive index. Less the temperature, more the refractive index. That is the idea. Third factor is wavelength of light. Wavelength. It depends on wavelength, and the fourth factor is color. Refractive index depends on the color of light also. Every color differs in the value of refractive index. Some color bends most, some color bends less. You know that. Do you know which color bends the most? Yeah, violet bends the most. That is correct. And the red bends the least. That means refractive index of which color will be most highest? Violet, because violet is refracting the most. Violet is refracting the most, that means refractive index the value will be the highest, and the red refractive index value will be the lowest. Red has got longest wavelength, and the violet has got shortest wavelength. If the wavelength is more, refractive index is less. If the wavelength is less, that is violet, that means the refractive index is more. That is inversely proportional. But you have to know about the color. Which color has got highest refractive index? Violet. That mu V is bigger than mu for red. I write like this. Refractive index of the violet is bigger than the refractive index of red color. Which color travels faster in air? Violet or the red? Tell me. Yes. In the air, they all have equal speed. Why? Because the refractive index of air is 1. Refractive is nearly 1. If it is 1, then C and D will be equal. That means they all will travel, all the colors will travel with the same speed in vacuum and in the air. Their speed changes only when they travel in different mediums, such as glass, such as water, such as some other medium. Then only their speed changes. And there the ray travels the fastest, and the other color will travel slower. If they give you the choice between blue and the red, which will travel faster? We say red. Which will travel the slower? We say blue in that case. Because blue is going to bend most, that's why it is slowing down more over there in the another medium. And that is why it bends more. This is the reason. Is it understood? Yes? All the colors have equal speed in air or in vacuum. But in another medium, the speed will be different. What is the ratio of the speeds in the air? If they ask like one question, a ray of light is traveling from traveling in the a blue color. They say blue color is traveling from blue and the red color both travel in the air. What is the ratio of the speeds? You say 1:1 because they are having same speed. But in different medium, the speeds ratio will change. Over there, the violet will travel slower and the red will travel fastest. Hope you understood this part. Okay? Yes? Okay. Now, you have to learn some diagram. Okay, the refraction. This is a surface separating two medium, medium 1 and medium 2. Medium 1 may be rarer medium, medium 2 may be a denser medium. Ray of light is traveling like this, rarer to denser. We put the arrow. This arrow shows all the rays are coming. Where is the incident ray? This is the incident ray coming. Here you draw normal. Normal will be perpendicular to the surface. Perpendicular, normal. Where will the ray bend? Ray bends towards the normal. Because here the speed is slowing down. Here is coming fast speed. Here is suddenly the speed is decreasing. So, refraction taking place here, or the bending of light is taking place. Or we say there is change in the direction of light. When it travels from one medium to the another medium from the surface, separating the two medium. This is called incident ray, this is called refracted ray. This angle is denoted by line, we call it angle of incidence. This angle is called angle of refraction. But practically a part of ray of light is reflected as well. There will be reflection also. Whenever there is refraction, this is refracted ray. There will be reflected ray also, but this is partially reflected ray. Partially reflected ray. Why partially? Because this contains much less amount of energy, nearly 2%. 98% will be available here, only 2% will go there out of 100% of the incident ray. But this ray will be always there for practical purpose. We do not draw it because this contains much less amount of energy. But in question, if they ask you identify this ray, you identify this ray as partially reflected ray. This is refracted ray, partially reflected ray right here. This ray always will be there, and this is called incident ray. This ray is called incident ray. Okay. Now, this angle is called angle of incidence. What is the angle of incidence? Angle which the incident ray makes with the normal, not with the surface. You have to take the angle with the normal line. And what is the angle of refraction denoted by R? The angle which the refracted ray makes with the normal. This angle is called angle of refraction. How are these two angles related? I and R. How are they related to one another? Tell me one of you. How are the angle I and R related to one another? What is the relationship between I and R? Are they equal? Amarnath? Anyone? Then what is the relationship between them? Yes, that is the relationship. If they ask write the relationship between them, don't write I is bigger than R. I think last time I told you. You have to write sin I by sin R is equal to constant, that is mu. You have to write this relation. Sin I by sin R equal to mu. You have to write like this relationship. Don't say I is bigger than R or I is smaller than R or even I equal to R. Don't say that. You have to say this. Okay? Yes? Now similarly, when the ray travels from denser to the rarer medium, this is denser, this is rarer, here is the normal. Where does it go? It will bend away from the normal. So this is the angle of incidence and this will be the angle of refraction. When the ray travels from denser to the rarer medium, it will bend away from the normal. When it travels from rarer to the denser medium, it will bend towards the normal. I think you know it is fact, isn't it? Here, find out the missing ray. Which is the missing ray over here? Can you see? Partially reflected ray. And that will be in the denser medium. If they ask, then we have to always draw. Missing ray if they ask. If they don't ask, we will not draw. Okay. Now another one. Ray of light is traveling from one medium to the another medium, but without refraction. Is it possible? Ray of light is traveling from one medium to the another medium and no refraction taking place. Is it possible? When is it possible? Tell me, when is it possible? Yeah, when the ray of light passes the surface. Passes the surface separating the two media normally. There are two conditions for no refraction. One condition is this one. So surface is this is rarer medium, medium 1 and medium 2. Ray of light is coming like this way. Along the normal line is coming, then it will go straight without bending. The ray of light is passing normally through the surface separating the two media. Then the refraction will not take place. What is the angle of incidence here in this case? Not 90 degrees, 0 degree. R also 0 degree. Why 0 degree? Because angle of incidence and angle of refraction you always take with the normal. And here the ray coming along the normal. The ray itself is coming along the normal line, So it will go straight. I is 0 and R is also 0 degree. Don't write 90 degree. When you see the rays coming along the normal length, I will be 0 degree, not 90 degree. Remember it. So this is one condition. What is the other condition for no refraction to take place? Do you know? What is the other condition? Ray of light is going from medium 1, this is medium 1, this is medium 2, and yet not refracting. Is it possible? Yes. When will that be possible? Ray of light is going like this straight without bending. That means this time the angle I, this is normal here. Normal should look like properly. This is I, this angle R will be equal. That is only possible when the refractive index of this medium and refractive index of this medium are equal. That is, if this is mu1 and this is mu2 and they are equal, then only this will happen. When mu1 is equal to mu2, then only this will happen. The ray will pass the surface without bending. When the refractive index of the two media are equal. Understood? Yes? Huh? Okay, these are the two conditions when no refraction takes place. Okay. Now, there is a principle called principle of reversibility of light. Principle of reversibility of light. Reversibility of light. What is this principle? It states that the path of a ray of light is reversible. What is the meaning of this? When the ray of light travels from one medium to the another medium, refraction taking place. If the ray starts from the second medium, then it will follow the same path as it was following while traveling from medium 1 to medium 2. I will show you the diagram like this. Suppose the ray of light starts here. Then it's bending like this. Now if the ray starts from this point, same point if it starts, then it will follow the same path. It will not be having different angles. These two pair of angles will remain the same. The pair of angles will not change. So this principle is called principle of reversibility of light. The path of ray of light is reversible. If here is the object, here is the image. If this is the object, here is the image. Just a reverse. Reverse is always true. From the principle of reversibility of light, we write this fact. We write 2, 1. Refractive index of medium 2 with respect to 1 will be equal to 1 upon 2, 1. Like this. We can interchange these two. Refractive index of medium 1 with respect to medium 2. Suppose I write refractive index of glass with respect to air is 1.5. What is the value of refractive index of air with respect to glass? It will just reciprocal of this 1 by 1.5. Point you can remove 2 by 3, divide answer becomes 0.66, 0.67. When you interchange a medium, when you reverse the medium, it becomes reciprocal. So sometimes you may get a fill in the blank that question also coming like this. 1 mu2 into 2 mu1 is equal to how much? They are asking fill the blank. How much will fill? Tell me. What will you fill in the blank? Say fast. Okay, fast. Can you get me? Are you able to get me? 1 into 2 mu1 will be how much? Say faster. Why are you reading so much? What's the mean? You don't see this equation. 1 mu2 cross multiply 2 mu1 is coming how much? Alright? The right here 1 you write here. This and this multiply answer is how much? 1 or not? Two reciprocal quantities of each other when you multiply, the answer will come always 1. If A and B are reciprocal, that is AB value will be 1. As simple as that. You don't know that. If A is equal to 1 upon B, then AB value is coming how much? 1 upon that one. They are both of them reciprocal of each other by the principle of reversibility of right. The answer will come 1 only. Okay? Yes? The question may come fill the blank and you have to fill it like that. Now in the diagram, how do we show principle of reversibility in the series? Suppose they have given a diagram like this. Here, and they are showing a mirror. Mirror is lying like this. There is a plane mirror like this. Wait, net has gone. Just a minute. 1 minute. Issue with the date. Okay, question says this is suppose air, this is water, and this is a plane mirror. They is doing mirror, plane mirror. This ray, refracted ray, is striking the mirror at 90 degree. What will happen to the ray? There are some copy complete the path of ray of light. That when a ray strikes the mirror at 90 degree, that is I value 0 degree, so R value will be also 0, that is this will return back. It will follow the same path. The arrow you have to reverse yourself. Question may come, name the principle of light used in completing the diagram. You say principle of reversibility of light. Principle of reversibility of light. Understood? Okay, by chance if the mirror they show like this, if the mirror is kept like this way, parallel to this line, parallel to this, what will happen to the ray now? So this is 40 degree I guess and this is 25 degree. What will happen to this ray now? This ray will be now reflecting like this. And now it will go away from, this is denser water, this is air, so it will go away from the normal like this. And but the pair of angle will be the same. Air angle is 40 degree and water angle is 25 degrees. That angle will remain the same. 40 degree and 25 degree will remain the same. These two pair of angle will remain the same. This is how you will complete. If they ask you find the missing rays, which are the missing rays? Can tell me. What are missing rays here? Is there any ray missing out? Huh? Where are they? Where will you draw them? Where? Over here. You have to draw two parts of this picture. One will be here and one will be here. Like this. Yes. Huh? Okay. Alright. Now the next topic is refraction of light through a glass block. Refraction of light through a glass slab or glass block, rectangular glass block. For this we draw the diagram like this. We take a block, glass block, and the ray of light is coming like this, and we have to show how the refraction taking place here. This angle is angle of incidence. Where will the ray go? The ray will be bending towards the normal, somewhere this side. This angle is R. Here we draw another normal. Again it will bend away from the normal. But which way away? For that we will extend this ray forward by dotted line. And here the ray you have to draw, it will go away in such a way that this ray must be parallel. It should approximately look like parallel like this. This ray should look like parallel like this. This ray should look like parallel. This ray is called incident ray, this is called refracted ray, and this ray is called emergent ray. Angle I, angle our refraction. This angle is angle of E, denoted by angle E, and it's called angle of emergence. Incident ray and the emergent ray will be always parallel. Why they are parallel? Because these two rays are contained by two parallel sides. This side and this side are parallel. So these two parallel sides are having these two rays. That's why this ray and this rays are always parallel. Two angles are always equal here. These two angles, angle I and angle E, will be equal because same pair of medium, air and glass. Here also glass and air. So air angle and air angle must be equal in values. Principle of reversibility. By chance, if the medium is different, this side is air glass and this side glass and water, then they will not be equal. But if the medium is same, generally the medium is same, then I and E will be equal. Here we show one more thing, that is called lateral displacement. This distance, shortest distance between them, this one, perpendicular distance between them is called, this distance is called lateral displacement. We can write in short LD. LD is lateral displacement. Lateral displacement. Or lateral shift we call it. Lateral displacement or lateral shift. What is the definition of lateral displacement or lateral shift? The shortest distance between the incident ray and the emergent ray. The shortest distance, that is perpendicular distance, is called lateral displacement. Now the lateral displacement depends on what factors? It depends on four factors. First one is angle of incidence I, more the value phi, more the value of LD. It depends upon the refractive index of the material of the glass, refractive index. If the refractive index is more, the more refraction will take place, the lateral displacement also will be more. And it depends upon the thickness of the block. Thickness, more the thickness, more the lateral displacement, less the thickness, less the lateral displacement. And it depends upon the color or the wavelength of light. Can you guess which color will have the highest value of lateral displacement? Violet or the red? Violet, because violet will be at the bottom. Violet is bending the most. Red will be bending less. So from the red the distance will be less, and from the violet the distance will be more. That is the idea. So which color will have highest value of higher value of lateral displacement? We say violet. And which color will have low value? Red, because red bends the least. Now, when will the lateral displacement be zero? When will there be no lateral displacement through a glass block? The answer is when the ray of light passes the surface normally, like this. If the ray of light passes like this way, 90 degree, it will go straight. It will continue going straight without bending, like this. What is the value of lateral displacement? There is no lateral displacement because the same rays is passing out. We don't have two parallel rays. So lateral displacement value is zero. Lateral displacement is zero in this case, minimum. And when will that happen? When I is how much degree? What is value of phi? For what angle of incidence the lateral displacement is zero or minimum? For what angle? When I is 0 degree, yes. And when will the lateral displacement be maximum? For what angle it will be maximum? Draw that angle. When I is 90 degree, yes. Like this. The ray must come. This is normal here. Ray must come like this way. Ray is coming like this. Or here the angle of incidence is 90 degree. I will now at 90 degree. Here the ray is coming along the normal line only. But now the ray is coming this way, whereas the normal is here. Now the ray will be bending. Here also it will bend. It will go like this. This angle also will be 90 degree. I 90 degree, E also 90 degree. What is the value of maximum lateral displacement? This ray will extend dotted line here. This is the perpendicular distance coming between them. This ray is parallel. So this is the value of lateral displacement. This only will be the value of LD. That means LD will be equal to thickness. Thickness of block. Thickness of the glass block. That is the maximum value of lateral displacement. maximum vector displacement will be equal to the thickness of the glass block. If the thickness of the glass block is 6 cm, then maximum vector displacement value will also be 6 cm. And for what angle it will be? For the angle of incidence 90 degrees. You have to show like this. This way the rays coming, normal is here. This way you have to draw the diagram. Even question may come draw the diagram to show the maximum vector displacement through a glass block. And what is the value of the maximum vector displacement? It will be equal to the thickness of the block, thickness of the glass block. Understood? Okay. So today we do till here.